All right, this video is for the second half of 3-2 notes. We are on example 4. Yesterday we talked about extremely low and extremely high, or significantly low and significantly high. How do we calculate that? What's considered to be a significantly low value and a significantly high value?
Outliers.
Kind of like the outliers, but how do I designate like that range, like the cutoff mark of who's considered to be like significantly short or significantly tall? How do I figure that out? The standard deviation. So we use the average, right? And we said yesterday for girls, the average was 65 inches and the standard deviation was 3.5. So we add 3.5, but we do it twice. And then we subtract 3.5 and we do that twice. And it gives us those cutoff marks for significantly low, significantly high. They will ask you those questions on the homework assignment. Thank you. Stuck helping us again. Okay. All right, now the next thing is something called the range rule of thumb. I've kind of marked up this paper, so circle that so you can see it really good. The range rule of thumb. And this is just a fast, easy way of calculating standard deviation. Fast calculation of standard deviation is the range rule of thumb. The range rule of thumb, a fast, easy way to calculate standard deviation. It's not quite as accurate, but it's a fast way to just kind of figure that number out, okay? And all you do is you take the range and you divide by 4. How do you do the range again? The max minus the min, the large minus the small, and you divide by 4, and that gives you approximately what the standard deviation is. It's not exactly accurate, but it's a fast, easy calculation, okay? That is called the range rule, I'm writing it real big so you can find it when you do your homework assignment, of thumb. Range rule of thumb for standard deviation. You take the range, divide by 4, that gives you approximately what the standard deviation is. Good? Happy with that? Not too hard. Let's go to example 4. They're going to actually have us do that. So using the 50 Verizon data speeds in this data set, they're not going to give me all 50 of them because to do the range, I only need the max and the min, the biggest and the smallest, right? Okay, so it says that the mean, oh, wait a second. The mean is 17.6 and the standard deviation is 16.02. Oh, they don't want us to do the range rule of thumb here. Okay, we're going to do that in example 5. It says the mean, we'll call them x bar, equals 17.6. The standard deviation is 16.02. Find whether or not 77.8 is considered to be a significantly high value. That's what they're asking. Is it a high value? I don't know. We're going to decide. Okay? How do we decide whether 77.8 is a high value or not? $77.8. Yeah, we're going to add. So starting with the average in the middle, which is 17.6, standard deviation is adding 2 of those to get my high value. This is my high value. Okay? If I take 17.6 and I add 16.02 and 16.02 again, it's like adding 32.04 to 17.6. What is that number? Somebody find that number for me. 17.6 plus 16.02 plus 16.02 again. 41.64? 49.64. 49.64. So that means that any value that is bigger than 49.64 is what?
High.
Significantly high. So now what?
It is high.
77.8 is it significantly high? Yes. It's considered a kind of an outlier number, right? A significantly high number. Make sense? Good? Now, the range rule of thumb for estimating the standard deviation. We're going to do that in this next one. So, use the range rule of thumb for estimating standard deviation of a sample of 50 data speeds. They say that there is a maximum number of 77.8 and a minimum data speed of 0.8. I think the 0.8 is whatever airport that I'm in because it's always crappy. That number follows me around, I guess. Max, min, Standard deviation, the range rule of thumb says the standard deviation, what does this little symbol mean? They used it above. What does this thing mean? Approximately or about. Okay, so it's just an approximation. It's not exactly the standard deviation. Okay, standard deviation is approximately that amount. We would take 77.8 minus 0.8 and we divide by 4. We always divide by 4, right? Okay, so that's 77 divided by 4, which is something. What's the standard deviation approximately? What? 19.25. They said that the actual standard deviation was what? 1602. Okay, we calculated a really quick standard deviation of 19.25. Not completely accurate, but it's a really fast and easy way of doing it, right? They have found that the standard deviation comes out to be approximately 1/4 of the range. Okay, that's why it's the range rule of thumb. Okay, good? That's example 5. Okay. Good? Good? Okay, population standard deviation is this formula that's on the back side, so flip over to the next page. They give you a formula for population standard deviation, but they use, and it's the same as the regular standard deviation, but they use different symbols. The standard deviation from the front side, they called it S, and they did the square root of the sum of all the x minus x bar over lowercase n. That's what the standard deviation formula was for a sample. They're saying you calculate it the same for a population, but it uses different symbols. Okay, so let's go over kind of these different symbols. This guy is called sigma. That's his pronunciation. He's like a circle with a hat on him, right? Circle with a hat. And he's called sigma. And he stands for the population standard deviation. Okay, they will use these symbols and you'll be like, what the heck does that mean? Here you go, label them. Sigma, he's the population standard deviation. Okay, this guy is the sample standard deviation. We knew that. S is sample standard deviation. That makes sense, right? Okay, what do these X's in here mean again? For those formulas, what's that X mean? Each data value. Oop. Each value and each value. Okay. Do you remember what this guy was pronounced as? This little cursive U. What's his name? Mu. Mu. He's called Mu. That's legit what his name is. Mu. And what does he stand for? He's got to be something for the population. Let's go over to this guy. X bar. What is X bar?
Average.
X bar is the average of the sample. So mu is the average of the population, right? Population average versus sample average. It's just the same formula, but two different symbols. So you know whether we're talking about a population or we're talking about a sample. Okay, and then let's do N. So capital N versus lowercase n. The number in the population versus the number in the sample. Okay, we've written all of these down before, I think. But here it is again, all right? Because I know they ask you on your homework assignment some of the different symbols and what they mean, okay? All right, because we do use these symbols throughout calculations throughout the rest of the basically year. So sigma, S, NN, X bar, mu, those types of things. We'll see those again. Caution. When using a calculator to find standard deviation, identify the notation used by the particular calculator so you get the sample standard deviation, not the population standard deviation. I'll tell you when we get to that if that's a problem. So don't worry about that caution. I will warn you of that when we get to that. Okay, variance. Variance is equal to the standard deviation squared. Maybe you knew that. Did you know that already? The standard deviation squared. What happens if we have the standard deviation and we're trying to find the variance, we square it? What happens if we have the variance and we're trying to find the standard deviation? Yeah, so the variance, the square root of the variance is equal to the standard deviation. That's another way of saying this thing, right? Variance is equal to the standard deviation squared, or standard deviation is equal to the square root of the variance, right? So if you have one and you're trying to find the other, you just do that thing to it, right? Whatever you're needing to do, okay? So variance, the symbol for variance, if the standard deviation for a sample is S, I'm going to do sample, and the sample or the population standard deviation is sigma, the variance only makes sense that this would be S squared and sigma squared. Yeah? That's the symbol that they will use for variance. Make sense? That only makes sense, right? S and S squared, sigma squared, right? Okay, now, a lot of questions going forward is going to be using this chart, and I have laminated it for you, and given the fact that it's laminated, just tells you how often we will use this chart. There's stuff on the back side of it. Don't worry about that for right now. We will use that maybe later. But this chart, the laminated chart, is a chart of this guy. Okay, ready? Some old dead guy came up with this, and this is called the empirical rule. And basically what happened is he took data set after data set after data set after data set, and he found that 68% of all data in each data set lies within one standard deviation of the mean. Okay, so let me give you an example of that. Okay, I'm going to use my really easy example that I did yesterday. We're going to say that the average that you guys scored on a test was an 85 with a standard deviation of 5. Okay, so according to the empirical rule, if I have 85 here in the middle, I can subtract 5 and I can add 5, and that range will be 80 to 90, okay? And according to the empirical rule, if this data is normally distributed, do you see the bell curve? If the data is normally distributed, we can say that approximately 68% of my students scored in that range from 80 to 90. That's what the empirical rule says. Yeah? That's what he says, okay? Now, in addition to that, 2 standard deviations would be 95%, okay? So let's do another standard deviation. If I subtract 5 and add 5 more, that would be 75 to 95, right? And according to the empirical rule, this says that 95% of my students are going to score in that range. Does that make sense? Yeah, maybe? Okay. Now, what percent is within 3 standard deviations? 99.7, right? And 3 standard deviations according to this would be 70 to 100. Oh, I ran out of room. 70 to 100, right? Do you see that? 99.7% of my students will have scored between a 70 and a 90 as long as this is normally distributed, okay? To come up with this table, this guy looked at table after table after table and data values, all of them, and came up with about 68% consistently was within 1 standard deviation. About 95 consistently was within 2 standard deviations. 99.7 was within 3 standard deviations, okay? Now, 99.7 still doesn't cover everybody because you can still be outside of 3 standard deviations. So maybe we still had a person over here, probably Caleb, that scored a 68, right? Right, Caleb? Sure. Okay. So it's not 100%, right? There still might be like one person that trickles every once in a while outside of that range, but for the most part, that's what happens, okay? Now, I really like this table and the way that it breaks it down because also it says the individual percentages, like 34.13 and 34.13. They have taken this 68% and they split it in half. And they said 34.13% is in this range and 34.13% is within this range, okay? So in addition to the 68 and the 68, 34.13% scored between an 85 and a 90. Do you see how that works? Does that make sense? Okay? All right, I'm going to ask you some, I'm going to quiz you some questions here. What percent of people scored between a 75 and an 80? Okay, 75 and 80 would be like this guy right here. 75 and 80. Do you see that? 13.59, Ellie said. Yeah? Does this make sense? Okay, I'm giving you lots of information, but hopefully this table is pretty straightforward. Is it okay? Like we understand how this works? Okay. We're going to be doing stuff with birth weight here in just a little bit, and not in a couple days, I guess. And you guys are going to figure out what percent is what, right? Okay.